Apple came up with SF symbols to handle most used icons and images natively. SF symbols are scalable vector graphics and can be rendered in any size. This fits the need of growing number of devices with different screen sizes. One side it solves one issue of image availability but create a separate issue on the other side as it promotes the strings in the code base. More strings in a code base is an issue for a good and clean coders. In today's video, we will learn how to make SF symbols type safe. Before we get started with SF symbol and how to create a type safe version of SF symbols, let's take a look of this project and see what the real problem is. So there's a tiny project in here which we have an image, we have a label right here, and as well as we have a button which is of course having another label on it. But the problem is, as soon as you can see that there is system name and this is an absolute string. So if I mistype with this E with the R, and we can see like it will stop rendering. So the problem with this that it has to be exactly the same. So I cannot misspell, and if I misspell, the image would not show. So let's say when I'm typing star instead of R, I type E. Images would not show. And if we are using these symbols in our throughout the project, or it is very highly likely that we might typo it. SF symbols is not type safe because it's binded with the string. Now I'm going to show you how we can go ahead and create a type safe version of this. And I am currently on iOS 14, so it will be nice if we can start with at available iOS 14.0. We are trying to create a mapping of all the symbols that are in our project here that will create a mapping and a safe symbol. So instead of using its string variant, we'll use something called safe symbols. And it is conforming to string. Since we are creating the cases, and generally it's a best practice that your identifier name should not start with a number. So to overcome that, creating a one dot circle will start with one with underscore and one circle, and another one have a star, and then we have square. Since we are conforming to the string, what we're going to do, we have to have the raw type, so called raw value switch on itself. All we have to do is just return the actual string. So best part about it is that since we are creating this mapping, this file would not be get updated as the code is being used. If there is a new image is needed, we'll just add it here, make sure there is no typo, and after that we can start its type safe version. In previous episodes, we have used the call as function, which gives us ability of our enum calling it without raw value as it's just a function. So if we implement So call as function will return its raw value. So this is the basic that we have to do to create the mapping. Now the next step would be how to use or leverage this strong typing that we have created over here. Let's dig up the documentation to figure it out what kind of convenience initializer that we have to write instead of this string type system name. Let's dig into image, look up the image, and if you look up a little bit, okay, this is right here, it's public init. This is what we will be writing when we are creating extension that will be abstracting the system image. Go back and let's see what's for the label. So as you can see, we already have extension on the label which do the title text and the icon as an image. Let's have a system image name, this. So we are going to use initializer and we'll write a convenience initializer based on this one. Another one would be where the title as image name and S is a string protocol. Another convenience initializer that we will be used for label will be based on this one. So let's go back and let's get started. Let's create another extension that will be on SwiftUI image. Since for this one, the necessary part is that we have to have SwiftUI. So before we import, let's make sure that we can actually import SwiftUI. So for that, we have this pragma here. Now we'll create a public extension on a SwiftUI image. Next step would be for initiating the SwiftUI with SFSymbol. Let's call it a SFSymbol. So this is it. This is all we need. We'll go back to the content view and start replacing wherever we are using the image with the SFSymbol. Now I'm just going to copy the whole this V stack, call it a SFSymbol. Now first one is an image, which is a system name. Now we can actually replace this with SFSymbol. So instead of this, we can call it image SFSymbol, and here we can use type safe version of one circle. And if you resume, there is literally no difference. So let's change this one to green. Now let's say where all we have image in the label, but we have not written the extension on a label. Okay, so I think there was only one instance of an image. We have changed that. Now the next would be a label where we are going to write the extension on the label. Now this extension on the label is going to be a little bit different to make sure that we have proper text and the icon image. Just follow along. For the second initializer, we'll use the disfavored overload. And that's it. Now we can go back to the content view and start applying this new initializer that we wrote through SFSymbol. I'm going to use the title key and the SFSymbol. Or maybe we can just try to use the square here. You can get rid of this image here too. Bravo, there is literally no change. We see everywhere where there is a string, we have now a type safe value. So as we can see that we have two variants of SF symbols. One is based on the image, which is easily can be mistyped, And now we have a type safe version where we are mapping it through the enum, and this way our code is always going to be with the less strings. Today's episode was all about going from a type unsafe code to a type safe code. For more tips, tricks, same as this, don't forget to subscribe, hit the notification bell, as well as the like button. See you on the next episode. Bye bye.